Good morning, students, and welcome to Data Communications Computer Networks. All right. So today I'm going to teach you how to do the laboratory experiment number one. No, it's all about packet tracer. Okay. So objectives of this experiment are to be familiar or to become familiar with the network simulator, no, packet tracer. Okay, and to use the packet tracer to simulate a simple network. So Chure background. So router and switch. No, I think you need to know what is a router and what is a switch. No, you need to differentiate these two devices. Okay, so routers are computers and include many of the same hardware and software components found in a typical personal computers, no, such as CPU, random access memory, random on the ROM, and, and an operating system. Okay, so the main purpose of a router is to connect multiple networks. Okay, so take note of that and forward packets from one network to the next. When you say packets, like a set of informations, no, will be forwarded from one network to another. All right, and this means that the router, okay, typically has multiple interfaces. Okay, so each interface is a member or host on a different IP network. Okay, IP network. Right. So the router has a routing table, which is a list of network known by the router. Okay, so the router or the routing table includes network addresses for its own interface. Okay, and which are directly connected to the network, as well as network addresses or remote networks. Okay, all right. So a remote network is a network that can only be reached by forwarding the packet to another router. Okay, so it's like a communication between two routers, no, in another remote networks. Okay, so remote networks are added to the routing table in two ways, either by the network administrator, manually configuring static routes, or by implementing a dynamic routing protocol. So static routes do not have much overhead as dynamic routing protocols. However, static routes can require more maintenance if the topology or if your connections, no, uh, is constantly changing, no, or unstable, right? So a router usually has fast Ethernet interfaces, no, for connections to different LANs and various types of WAN interface to connect a variety of serial links, including T1, DSL, and ISDN. Okay, so this is the physical representation of a router, no, interfaces. Okay, so it has a lot of connections, no, at the back, no, of the router. Okay, then the network switch plays an integral part in most Ethernet LANs. Okay, Ethernet LANs or interconnected networks, no, LANs. Mid to large size LANs contain a number of link managed switches. So a switch operates at a data link layer, no, in your OSI layers. So this switch operates in a somewhere in the data link, no, yeah, in a OSI model to create a different collision domain, no, per switch port. Okay, so similar components available on switches as described above for routers. A switch has a console port for management and a set of internet faces Ethernet interfaces for LANs connections. Okay, so this is an example, a physical example of a switch. Okay, it has how many ports? 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3, that will be 24 ports. Now, now packet tracer, no? When you say packet tracer, okay, it's a protocol simulator. It's a simulator, no, where you can build your own networks, no, for testing, no, before deploying it in a real physical configuration, no. So this was developed by Dennis Frezzo, no, and his team at Cisco Systems. Okay, so Packet Tracer or PT is a powerful and a dynamic tool that displays the various protocols used in networking in either real-time or simulation mode. So this includes layer 2 protocols such as Ethernet and PPP. UDP. So layer 3 protocols such as no, IP, ICMP, and ARP. Okay, and layer 4 protocols such as TCP and UDP. All right. So routing protocols can also be traced. And before starting the following procedures below, you should download. No, you should download the Packet Tracer simulation tool on your PC from the following link. I think if Dr. Mohanad or the teacher already discusses this to you, I hope that your teacher, the faculty in charge, already instruct you to download your Packet Tracers and as well as you need to sign up no on that Packet Tracer. All right. So introduction to Packet Tracer interface, using hub topology. All right. Now, let us. Would like uh, to present to you the new Packet Tracer, no, the new environment of the Packet Tracer because I think this is the old Packet Tracer, not the old version. Okay. So, all right. Now, okay, so what you need to do is that once you download your Packet Tracer, then install it. Okay, when you install the software, then you can sign in or sign up first, and before signing in that in the Packet Tracer because it will ask you to sign in, no, before you can use your Packet Tracer. All right, so click okay, open your Packet Tracer. No, I will open it now. My laptop as well. Okay. So now this is now my Packet Tracer, no? So I need to log in, no? So gonna log in user my username or email, no? My personal email, and as well as I'm going to also to put my password. Okay. All right. Okay. So here we go. No, this is your the Packet Tracer now. Okay. So Packet Tracers above. No, you can find the tabs: File, Edit, Options, View, Tools, Extensions, and Help. And some tools that you're going to use during your uh, uh, designing stage, no, of your network. Okay. And here below at the left side bottom, here you can see the different components, no. So you have the network device, no. Once you click it, the network device, it will take you to the different devices, no, of networks. Okay, you have here the routers, the switches, the hubs, the wireless services, okay, the security, and the wide area network emulation. Okay, no, I think this one is used by for the internet, right? So if once you click the routers, then at the middle you will see different routers, no, different types of routers. Okay, depending on what your configuration needed. Okay, but most of the time we are using this is either PT router or PTMT router. Okay, all right, but anyhow, no, during the laboratories, in the coming laboratories, the router devices, no, the router devices will be given to you. Okay. Then, if you click the switches here, then you can see a lot of uh, switches, no, available, no, in the Packet Tracer. Okay. All right. Then you have the hubs, right? Different hubs, okay, and the wireless devices also. No, for example, no, you're using a wireless router, no, similar that you are using at home, no, the one that if you are, for example, no, if you are uh, connected to the Etisalat, right? If you are availing their eLife, no, so there's a router, no, being installed there, no, wirelessly, so that in every corner of your house, no, you can get the Wi-Fi signal, no, and you'll be connected to the certain router, okay, and that router will go to the uh, to the connected to the internet, no, to the Etisalat. All right. Then you have the security and you have the wide area network. All right. Then here, the next component is the end devices. No, what devices you are going to use, no, during your design, no, or network designs. Okay. So you have end devices here, no. End devices, it comprises of PC, laptops, no, depending on what you need, no. PC, it will be physically, no, will be physically wired, no, using the Ethernet cables, and laptops can be used as a to be connected via wireless, no, via wireless or Wi-Fi, and the server where you can put all your datas, no, datas and to access datas or store and access datas. Then also the Meraki server, printers, iPhone, VoIP, smart devices, like your phone, wireless tablets, TVs, generic wire, and sniffer. Okay. All right. All right. So these are the end devices. No, you can also click home. No, in home you can have the different types of appliances. Now, for example, no, if you want to connect or to connect what you call the Internet of Things, no, that you want to connect your aircon, air conditioning, the coffee maker, okay, the battery, okay, the charger, no, your Bluetooth speaker, fan, door, and if you want to connect all of this into a wireless network, then you can do so, no, uh, through the Cisco Packet Tracer. Okay, then you have the smart city, no, if you want to build a smart city on your network, for industrial also, no, for fire alarms, okay, uh, the carbon dioxide detectors, okay, the sprinkler of the fire, like fire sprinkler, no, if there's in case if there's a fire, no, will going to happen. Okay, and we have also the power grid, no, power grid, no, for example, no, uh, a, a certain renewable energy devices, no, that's being used, no, in your network to supply, no, to supply uh, your appliances or home, like with the external power grid. Okay, so you can do also that, no, uh, to connect it to your network devices. All right, and as well as some components, electronic components, no, like for this one, no, I think this one is like similar to a microcontrollers, no, so you can use also this. Okay, then diodes, no, electronic devices, no, diodes, LCDs, like a sensor heating element, uh, LED, okay, or temperature or air cooler, okay, and some a speaker, no, you can also use that one, and also a control, no, control sensors, okay. These sensors are can be used, no, to sense, no, for example, if you have a projects, no, projects that you want to test, no, using different types of sensors, no, available in Packet Tracer. We have the water sensor, we have the water detector, the tripwire, the wind sensor, the toggle push button, temperature sensor, and the photo sensors, no. So if you want to test all these sensors, no, in your networks, so that if you want to sample, if you want to trigger, no, I mean you want to monitor, no, the wind, the temperature, no, of a certain environment or a room, then via wirelessly and connected to a network. Okay, you can do also here in the Cisco Packet Tracer. All right. So where you can draw your network? No, you can draw it here. Okay, in this blank white color at the middle. No, your design work area. Okay, here. Okay, so you just it's just very simple. No, for example, no, if I want to uh, let's say choose a router, no, simple PTMT router, okay, just like that, no, okay, you can drag and drop, okay, like that, no, then you can choose, let's say, PC, to connect PC, just drag and drop, okay, like that, no. So later on, we're going to show you how to connect, how to design, no, a simple router, no, or how to configure simple network, no, using a packet tracer. Okay. All right. So today So I'm gonna show you the introduction of Packet Tracer. No, I already shown to you what is Packet Tracer and how to interface, no, using a hub topology. Okay, all right. So choosing devices and connections. So we will begin building our networks topology by selecting devices and the media in which to connect them. Okay, several types of devices and network connections can be used. No, for this lab we will keep it simple by using end devices. Okay, we use end devices. Okay, then switches, hubs, and connections. Okay, so let us try to build the topology, no, by adding the host, no. Okay, so how to add the host? Okay, so what you need to do is that, okay, so you need to go to the end devices, all right, and choose the end devices, and then drag and drop the PC. Okay, so you need to add four PCs. Okay, all right, or personal computers, no. All right, so use the PC PT, right? Okay, this is the one. Okay, so drag and drop four pieces, right? Okay, sorry for that. No, I will delete this one, then I will create a new packet tracer file. Okay, so okay, so just to start with, okay, so new packet tracer. All right. Okay, so build the topology, okay, by adding the host. So add the PCs. Okay, so you need four pieces. One, two, three, and four. Okay. Now, once you add the PCs, once you add the four PCs, no, and the name of the PCs are PC0, PC1, PC2, and PC3. Okay. All right. So now next, building the topology, connection the host to hubs and switches. Okay. So you're going to connect this host to a certain uh, switch. Okay. So choose a hub. Okay. So go to the network devices. Okay. Network devices. Oh no. Yeah. Network devices, and uh, choose the hubs. Okay. So PT hub. Right. Okay, so put this one a little bit up like that. So connect the hub, PT hub uh, here, no? Put it here. And after putting it there, okay, so now connect PC0 to hub 0 by first choosing the connections, okay? So you're going to connect PC0 to hub 0. Okay, all right. So and then click once on the copper straight through cable. So go to the connections. Now here, no, this is our connections component, and look for the straight through, no, straight through. Okay, copper. Okay, I think this one. No, click it and click it to where you want to connect. So click to the PC and choose the fast Ethernet. No, fast Ethernet. Okay, like this, and connect it to the hub and connect also to the fast Ethernet 0. All right. So now they are connected. No, as you can see, there's a green color. No, green color triangles. No, so it means that it's connected. All right. Okay. So now then do also in PC1. Okay, and connect and have 0. Okay. So click the straight wire, fast Ethernet 0, and connect it to the fast Ethernet 1. Okay. So now in the hub, you already use the fast Ethernet 0 and fast Ethernet 1. Okay. All right. So repeat the steps. Okay. So we did it. No, we repeated it. Okay. Now select a switch by clicking one of the switches and once on 295024. Okay. So go to the networks and pick the switches. Then look for 295024. Okay. 295024. I think this is the one. No. So put this one a little bit up. that, like this, okay, and 295.024, right, like that, no? And do the same thing that you have done in the first, okay? Connect it using the fast Ethernet, I mean, using the straight through, no, copper wire, okay? So click the connections straight through, right? PC2 to the hub, like that, okay? And this one as well, no? So this one, pass Ethernet, and here, pass Ethernet 2. All right, okay. So notice that the green light in PC2 and IC and amber light in Ethernet port, okay? So there is a green here and there is a like a circle, no, orange color, no? So the switch port is temporarily not forward trained, okay? So it will take about 30 seconds, no? The amber light will change to green, okay? As you can see, no, it starting now to change into green color, okay? All right, so frames can now be forwarded out to the switch port. Okay, right. Okay, so move the cursor to the over the link light to view the port. No? FA means fast Ethernet, 100 Mbps. Is oh, sorry, sorry for that. So let us wait. So move the cursor over the link, okay, like that, no? And you can see an FA, no? FA meaning it's a fast Ethernet connection, no? Uh, it can transmit no signals or packets, no, with one through 100 Mbps. All right, configuring IP addresses and subnet mask. That's the step number. The next step is to configure IP addresses and subnet masks on the host. Okay? Before we can communicate between the hosts, we need to configure IP addresses and subnet masks on the devices. So click once on PC0. This once. Okay. Choose config tab. Okay, this one, no, config tab. All right. Then it's here that you can change the name of the PC. Okay, here. Okay. And it's also here where you would enter the gateway, okay, the default gateway addresses, also known as the default gateway. And we will discuss this later. But this would be the IP address of the local router. If you want, you can enter 192, no, 192.168.1.1. Okay, that right. Okay, and here's the physical. Okay, physical. So at the back of the PC, no, for their personal computer, right? And once you're done putting the default gateway, right? Then just wait a minute. Okay, this is your programming here. If you want to do some programming, then attributes, desktops, no? Where can you can also configure the IP address here, no? Like this. All right. Okay, but we will not do it now. We'll go here, no? To the Go to the config and click fast Ethernet. All right. Once you've done it, then type the static IP configuration. All right, so that is 192.168.1.10, and subnet NAS, of course, no, 255, okay, 255.255.0, right? Okay. All right. So, and this is your link local address. So once you're done, then repeat these steps, no, for the other host. Okay. Okay. So let us go to the others. So PC1 also. Right. So there is a table, no? Okay. There is a table in your lab manual to repeat all these no putting some putting the gateway and also the gateway address and also the fast internet addresses, no, using this table, no. So PC0, so we done already the PC0, this is already finished. Then we'll do PC1, PC2, and PC3. Okay. All right, so we'll do it now in the packet in our packet tracer. Okay, so click now PC1, right, config. So this is 192 uh, 19 192.168.168.1.1. Okay, and go to fast Ethernet. And in PC2, look at your table provided. So 192.168.1.11 and subnet mask. Right? Then click close. Okay, so do it also in PC2. Click PC2, go to config, and default gateway 192.168.1.1, right? And go to the fast Ethernet 0 here, and static address is in PC2 from your table 192.168.1.12 subnet mask. Okay, and then click close, and PC3 config default gateway is 192.168.1.1, and pass Ethernet, that is from the table, no, 192 in PC3 dot 168.1.13, then subnet mask, which is 255.255.255.0. All right. Now verify the information to verify the information that you entered. Move select tool arrow over each host. Okay. Okay, like that, no? So for example, in PC0, so look at there, no? You can see the default gateway, no? Default gateway and the IP address, no? That you have been created. Okay, like that, no? Right. So now connecting the hub now. Right. So how to connect the hub, this hub to the switch? Okay. So to connect the devices, okay. Sorry for that, no, for that emails. So to connect the devices like hub and a switch, we will use a crossover cable. Click once the crossover cable from the connections option. Okay. So look for the crossover. I think this is the one, no? Crossover with the broken lines. Click it and choose fast Ethernet 2 and click it here. Fast Internet 03, no, as indicated in the manual. Okay, so move the connection over the hub. Okay, and click once. Okay, and select the port. Okay, you already select the port, no? And okay, a minute. Okay, we already select the port and we already connected the crossover. So wait for 30 seconds, no, in order for this green color will, I mean this orange color circle, no, to switch into green. All right, now it's switching to green now, meaning they are connected, no? Okay, all right. So now the hub and the switch are already connected to each other, no? Okay, are connected to each other. Okay, right. Yeah, I like this. Okay, are connected to each other. Okay, right. So there you go. No, you already connect a network, no, a simple network, no, using the hub and the switch, no. Okay, so now let's go to the network simulation. In this part, we are going to use the simulator to simulate traffic between hosts. For this scenario, delete the switch and host PC3. then connect PC2 to the hub. Okay, so let us delete the switch. Okay, delete the switch. Okay, and PC3, right? Okay, escape. Then connect PC2, okay, to the hub. Okay, as indicated, no, in your procedure, no, of your laboratory number one. Then observe the flow of data from PC0 to PC1 by creating network traffic. So switch to the simulation mode. Okay, so click this one, simulation mode. All right, like this. So try, okay, for me, I want to bring it out, no, this one, so that I can see I can see all the details, no, and I can also edit the filters, no. I want, well, what filters I want to well, I mean, what events, no, I want to do, no, because there's a lot of events, no, being added, no, default in default. Okay, all right. So switch to simulation mode by selecting the tab that is partially hidden behind the real-time tab. In the bottom right-hand corner, the tab has an icon stopwatch. Okay, that's what we did, no, stopwatch. Note, when simulation mode is chosen, a simulation panel will appear on the right side of the screen. Okay, here, no, this is the one, no. This panel can be moved by moving the cursor at the top of the panel until it changes and then double clicking on it. Okay, that's what I have done, no. We move it and put it outside, no. The panel can be restored to original location by double clicking on the title bar. Okay, okay, you can like that, double click title bar, it will restore, no. But I want it to, you know, be outside of the main panel. Okay. Now, if the panel is closed, click on the event list button. Right. So click edit filters. Okay. Here, edit filters. Okay. Then select all. Right. All none. Okay. Okay. Or let's say here, no, show all none. Okay, like that. Then edit filters. Okay. Then choose ARP and ICMP and click in the workspace to close the edit filters window. Okay. So in the IPv4, in the visible elements, just choose ARP, no? ARP and the other one, ICMP. Okay, this one. That. Okay. Then close it. Okay. That, no? All right. So, and that's, I think RIP also you need, no? Click on the filters and then select all none. Select every filter. Okay, like that. You select, okay, like that, no? Click this show all to none to deselect. Then choose ARP, ICMP. Okay, close. Right. So select a simple PDU, no? So the PDU is here, no? This is the two of them. Okay, PDUs. Okay. Select a simple PDU by clicking close envelope. Okay, this one, no? The close envelope. Okay, and common toolbars, no? So move to PC and click establish source. So move to PC0 and click to establish source and move to PC1 and click to the establish destination. Okay. So let's say I will click this one. I will wait. I will okay. I'm going to click this and put it to the PC0 and select a destination. No, source and destination. Let's say I want to send it to PC1. All right, something like that. No, and notice the two envelopes are now positioned beside PC0. This is referred to as data traffic scenario. Okay, one envelope is an ICMP packet, and while the other one is an ARP packet. So the event list in the simulation panel will identify exactly, which envelope represents ICMP and which represents ARP. So select auto capture. Okay, or play, no, play button, no, this one, no, play button. No, okay. All right, so let's click that, no. So then now it's simulating now, no, the 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 envelopes, no, where it's being sent, no. So we set it to PC0, no, to PC1. Okay, so it's now simulating sending this PDU to the other PC, no. So look at here, no. If you try to look at the event list, so PC0 and PC0 two PC0s, it's sending ICMP and ARP, no, to the hub, no. Okay, so PC0 send ARP to the hub and to the PC1. All right. So here you can find all the events that you need, no. But obviously in the network here, uh, the the PDU are sending only to PC1 because we set that the destination will be on PC1, not on PC2. If you try to look at here, in the PC2 has this X, no, X marks. Okay, then reset simulation if you want to reset it, and if you want to run it again, like this. Okay, play. Okay, okay, you can use also this forward button, no, if you want to make it fast. Okay, that if you want to skip all the simulating part. Choose the power cycle devices. Choose the power cycle devices. Button on the bottom left above the device icon. It's the one, no? Power cycle devices. Okay. And it will ask configurations not in start configuration will be lost. Reset the network. Yes, reset the network. Okay, that. Okay, you can see all the envelopes where it's being sent. No? All right, that's it. That's your laboratory number one, and I hope that you learned something. And good luck to our to your experiment today. Please do this experiment, and while doing this, no, I'm going to ask some questions, no, ask some questions, or if you understand, no, what have I have been teaching you this morning, and it will be graded. Okay, so thank you and good luck.